We know that reversible chemical reactions strive to reach the condition of equilibrium because it is such a stable state. LeChatlier's principle states that if a chemical reaction is at equilibrium and a stress is applied to it, then the reaction will shift in such a way to offset the impact of the stress and regain equilibrium. And it's actually relatively easy to predict which way a shift will occur. For example, let's look at reactants. If I add nitrogen, then what that does is it changes the concentration of my reactants. And what that means is this ratio of products to reactants will no longer be equal to K. So the reaction is going to shift in such a way so that it can regain equilibrium. If I add nitrogen, then the chemical reaction will shift to the right. More nitrogen and hydrogen will react and more ammonia will form so it can get back to equilibrium concentrations. Now, if I remove a reactant, whether it's nitrogen or hydrogen, then again, that's going to change the concentrations and the reaction of hydrogen or nitrogen, whichever I remove, and thus the reaction will shift in a way to regain equilibrium concentration. So it will shift to the left. So if we remove a reactant, the reaction will shift to the left. If we add a reactant, the reaction will shift to the right. If I remove a product, the reaction will shift to the right, and if I add a product, the reaction will shift to the left. Now we can also look at the impact of increasing temperature, which means we add heat, or decreasing temperature, which means we remove heat. And the easiest way to predict the impact is to write heat either as a product, which it is for an exothermic reaction, or as a reactant, which it would be for an endothermic reaction. So for an exothermic reaction, if I add heat, the reaction will shift to the left. So if the temperature increases for an exothermic reaction, the reaction will shift to the left. If I remove heat or decrease the temperature, the reaction will shift to the right. And the opposite shifts would occur for an endothermic reaction where heat is a reactant. Table 9.5 of your textbook summarizes the impact of adding or removing reactant or product and the impact of temperature depending on whether we're looking at an endo or exothermic reaction.